Hello and a warm welcome to the AI with Arun Show. So, what is the single biggest challenge that technology needs to solve for a nation like India? How does a revolutionary idea go from a thought in a lab to a tool that changes millions of lives? And are we prepared for the true impact of quantum computing? So, these are not just theoretical questions, these are the daily reality of our guest today. So, we're joined by a leader who operates at the very frontier of innovation, Dr. Amith Singhee. He is the director of IBM Research in India and the CTO for IBM India and South Asia. He doesn't just predict the future, his lab's mandate is to invent it. So, today we're going to unlock his perspectives on the real problems AI is solving, demystify the power of quantum, and understand the strategic thinking that drives technological progress for one of the world's most iconic companies. Dr. Amit Singhee, a very warm welcome to the show.
Thank you, Arun. Very glad to be here.
This is an era where innovation is dominated, or at least seems to be dominated, by very fast moving startups and open source communities, right? So, what is the most unique and enduring mandate of a very large, very old industrial research lab like IBM Research? What are the class of problems, of an institution of that like yours that you guys are trying to solve, which other people cannot?
Yeah, I think that's a great question. Sometimes it's not obvious, perhaps, to people. So I'm happy to talk about it. We define our mission in IBM Research globally as a two-pronged mission. One is to be the growth engine for IBM, where growth and engine are important. And the second is to invent the future of computing. So the class of problems we look at is at the intersection of these two. And just a little bit, if I elaborate, if we talk about growth engine of IBM serves what we call as enterprises across the world. So these are typically large businesses like banks, retailers, insurance companies, public sector companies. And so these are not consumer facing products and services. These are for the large enterprises. For instance, 70-80% of credit card transactions are actually processed on IBM servers. And this has been happening for the last 5 decades. So people don't see that in the front end when you swipe your card, but that's where it happens in the back end. And so this gives us a unique vantage point. How does business look at technology? How does business look at computing? Which can sometimes be quite different from, let's say, how you or me as individuals might look at it, where we're trying to create content or make travel plans or whatever it might be. So we really focus on enterprise computing, making things that can scale and be adopted in large businesses, given all of their, the train has to keep running while they make changes. It's not a new train that they're building every time. That brings in unique problem statements of scalability, of security, of cost, of effective computing approaches. And we combine that with the latest in research that we do as we look at the future of computing, whether it's generative AI, whether it's quantum computing, whether it's semiconductor technology. All of these three are important vectors that the global team in IBM Research is working on. And we are very engaged with open source also. A lot of the work that we do and the assets we create, we also put into open source. Our models that we have created, like the Granite model family, are all open weight models. In fact, these were the first Apache 2 licensed models, which are backed by a company like IBM. And the reason we went with that approach is because we wanted enterprises to trust these models and not be second guessing them. It's just one example, but a lot of the tools we develop for, say, data preparation or for fine-tuning models, or even if you look at quantum, actually, our entire software platform for developing quantum programs, it's all open source. It's called Qiskit, and it's from the IBM Research division. So we straddle this, enterprises and how they move, the future of computing and open source. And I think this combination is pretty unique and keeps us pretty busy across the world.
So, Amit, a lot of our audience is excited to hear you speak about quantum, and we'll get to quantum a little later in the episode. But if possible, give an example of how a real-world problem, particularly in the Indian situation where you are located, how a real-world problem that you saw in the real world, how that influenced your research and you got to something that was finally into production. Any perfect example that you could possibly share with our audience?
Yeah, definitely. I'll take one actually from a few years ago. It was pre-GenAI, but I think it's an example of how, from the real world, we worked on it. It was actually in the retail sector with a company called Bestseller. If you know about brands like Veromoda, I think Jack and Jones. So Bestseller is a very large fast fashion company. It's a global company, but they have an India subsidiary that has been growing a lot. And we from IBM Research directly engaged with the Bestseller leadership team to understand what are their business challenges. And they had challenges in fast fashion where you actually have to decide your merchandise and your product portfolio 6 to 9 months in advance of when it will hit the market. And so you have to predict whether 6 9 months from now this product will be successful or not. And that is in a domain of fast fashion, not slow fashion. Fast fashion, changes in 3 months, as we all know. It's an extremely hard problem, and they relied completely on human judgment, more or less. Of course, they were also trying to take data techniques. So we found that as a perfect match with some of the research we were doing around computer vision, explainable AI, understanding images, and when you have these neural network approaches, how do you explain why it made a certain prediction? What were the factors? And we mapped all of that to their problem statement to help them with demand prediction for any candidate products they might be looking at, because it could analyze the images, it could use explainable AI to tell you which features and factors will influence the demand. And that actually got rolled out in Bestseller, and they find it really useful. So that's one example. So it helps us to validate the research we're doing in the real world, while also understanding the real world constraints, bringing that into the problem statements we look at. That's one example. There's lots of others, more recent times. But
yeah, no, that's a brilliant example, Amit. Amit, let's talk a little bit about the future of technology and very quickly on quantum. But before we come to quantum, what are some of the other technologies? So we already know a lot of people, audience already know about Gen AI. They know about AI agents, LLMs. What are some of the other technology that make you very excited?
See, what makes us excited and me excited is one is the application of these in the real world, and the other is the combination of these, right? So in IBM Research, we look at all these four areas: generative AI, quantum computing, hybrid cloud, and semiconductors. So when you look at them separately, they're all different. But when you look at them together, you realize that you can actually bring all of these together to go beyond any one of these good on their own. If you are building generative AI models and solutions, but if you can optimize the hardware, if you can optimize the hybrid cloud deployment architecture, you can actually do a much better job of achieving the same qualities with much more effective, cost-effective, and performance-effective stack. So we are able to bring our research at the hardware level, developing AI chips, and also our research at the platform as a service or hybrid cloud level, working with Kubernetes ecosystem and advancing the Kubernetes ecosystem for generative AI workloads, while also optimizing the AI applications that would work on this. So then when we look at quantum, we also then can see how quantum computing can help with machine learning, because quantum computing opens up the possibility of new kinds of kernel spaces that were not accessible by classical computing, which can open up new ways of learning from less data, learning more patterns from less data, because now you have access to more spaces to map your data to. And when we look at all of this from a hybrid cloud lens, we can also think about how these hybrid computing systems can be deployed, where you have quantum computers with GPU-based infrastructure, with CPU-based infrastructure, and HPC. How do you use all of that with hybrid algorithms to solve really hard problems? So this combination of things is particularly exciting. And then when we look at applications in the real world, where we can impact it.
Yeah, you're right, Amit. A lot of time we tend to think about individual technology trying to solve a problem, but it's really a combination of these technologies across the board that come together to solve one problem. So, Amit, you sort of started speaking about quantum, and let's get into quantum a little bit more. So, first, explain to our viewers what is quantum computing. I mean, I'm a 15-year-old. Explain to me.
Actually, 15-year-olds might already know it. But okay, one way that I like to think of it is leave aside all the notions we have of normal computing. It's leave aside bits and digits and numerical computing and logic and all of that, because none of that actually is applied in quantum computing. Quantum computing is really based on the principles of quantum mechanics, superposition, entanglement, and many other principles that are there. And at the core of it, you can think in this way that in digital computers, you have bits which can represent 0 and 1. And with that, you can represent numbers, you can represent words, you can do Boolean operations to do complex calculations, and then you can write programs to do all of that, right? Whereas in quantum computing, there's something called a qubit. Now, a qubit is a quantum bit. Think of it like an electron, right? So for people who know what an electron is, it's a small particle of matter, and it can exist in theory, as per quantum mechanics, you cannot know exactly what is its state, what is its position, what is its velocity. Heisenberg's uncertainty principle, people might have known. So imagine you had a bit which could be in multiple states at the same time, as long as you're not trying to measure it or check its value. And so in a way, it is representing multiple possibilities, not just one out of two. And so if you take 100 qubits and take them through certain transformation, physical transformation, then you sort of can compute multiple possibilities. And then finally, when you measure it, it will collapse onto one out of those multiple possibilities. So what you do is you keep doing that again and again and keep measuring to understand the probability of what the final answer would be. So you actually treat it like a quantum mechanical system, right? So people who know about the double slit experiment where you throw photons through it, when you throw one photon, it shows up in one place, but then you keep throwing multiple photons through it, and you start seeing a wave pattern. So that's like the multiple sampling you do through the quantum system, and that reveals to you what the actual answer is. So it works in this kind of quantum mechanical principle. But there's the trick now is how do you map real world problems, like if you have an optimization problem, onto this concept? Because this is a very different concept. You cannot just write an optimization mathematical way. You have to actually map it to that quantum mechanical construct. And that's where actually a lot of the research now is going to be in this algorithm discovery over the next 5-10 years to figure out how do we actually map real world problems, whether it's in drug discovery or in material science or in scientific domain or logistics, onto this conceptual paradigm. Hopefully that made
it does. And Amith, in your opinion, do you think that we are probably done with the digital world now, right? Or
no, not at all, because what will happen is quantum will get added to digital. It's not going to replace digital.
Okay, that was actually my next question. Yeah, how do you see it? Good. Okay, please go on.
Yes, so it's going to get added because it can now it will be able to address certain problems that digital cannot today. But it's not going to be able to do web services and transactions and running word processors and all of that. That still be digital, right? So all the things we do with digital, we can keep doing. But with quantum, we can add more capabilities. So we'll start seeing hybrid systems. Just like today, we see CPU and GPUs working together, even though both are classical. But it's not that GPUs are replacing the CPUs completely. They're being used for things that they do well. And then quantum will get added for things that it does well.
So, Amit, if I were to say that, in the future world, in the world that you are seeing it, so digital will continue to stay, as you said, and then we'll be solving here with unsolvable problems that the digital world cannot solve with quantum computing. Is that a fair way of looking at it?
Yes, with quantum-centric computing. So quantum plus digital together will solve those problems, additional problems that we could not solve today.
But all right, so let's switch gears a little bit. Let's talk about sustainable computing. So you are known to do a lot of work in the area of sustainable computing. So talk to our viewers about what exactly is sustainable computing and the kind of research that you are doing around it. Share some bits with us.
Yeah, so there's two lenses I can apply to it. One is how does computing itself be sustainable and use less energy and so on and so forth. And the other is how do you apply computing to sustainability problems? How do you apply AI and quantum computing to sustainability related problems? So on the first one, probably the best example I can take, and this is not just IBM Research, this is IBM Research and product teams working together. We build these highly engineered servers called IBM Z and IBM Linux One. These are also called mainframes, right? So people probably think of mainframes as some old stuff that nobody uses. But actually, mainframes are the one that run all those credit card transactions I was talking about in today's world, along with many other things. So these systems are optimized all the way from the semiconductor technology to the chip design to the way the entire rack is designed to the operating system to the middleware and to the software, all the way as a single engineered system. And it's a very different principle than, let's say, using lots and lots of small servers to make a cloud. When you're trying to make a cloud, you're really trying to have horizontal scaling. Whereas when you're trying to pack everything into a single system, you're trying to make sure that the system is extremely effective to solve the entire problem. And today mainframe computers, if you compare for the same workloads using, say, x86 or general servers, you can replace thousands of CPUs of x86 with a single mainframe system and save substantial amount of energy while achieving high performance, high reliability. Now to that, we have started adding AI hardware, and we are doing a hybrid technology where in the CPU of the mainframe, we are adding AI accelerators right in the CPU design. So that's an embedded accelerator. Plus, we are also adding cards in the drawers so that you also have access to more powerful accelerators on the PCIe cards. So this gives you a spectrum of capabilities. You have general purpose CPU, embedded, what we call MMA or a neural processing engine right on the CPU chip, and then you have the cards. So you can really optimize your workloads. You're not just blindly saying, let me just get a lot of GPUs and put things there. You can actually co-optimize everything. So that's one example.
Okay. So Amit, in your view, do you see a world? Do you see a world in which we? So today we are in a distributed computing world, right? Or the world seems to be going in that direction. But in your view, do you see a world where people are back to mainframe computing, or mainframe computing gaining more prominence than what it has, let's say, in the last 10 years or so, 20 years?
I see it continuing to sort of coexist, right? It's not that people are adding a lot of new mainframes, but the workload on mainframes are increasing. Because over the last 20, 30 years, we know that things have become much more digital. Banks have become digital, retailers have become digital, insurance companies are digital. That's going to keep happening. And what it means when they get digital is there's a lot more transactions volume that starts happening. Because now instead of going to the branch, taking 1 hour to do one transaction, you just take 10 seconds to do it. So that means in an hour now you have like millions of transactions coming into the bank. So that volume of workload on the mainframes are increasing. We are seeing now these mainframes were ZOS operating system based. We are seeing a lot of adoption on Linux based mainframe systems. That gives full flexibility of running any software that you could on Linux. Even in India, for instance, we are seeing a lot of interest in the banks to adopt these as they scale up their digital volumes. And then as the AI technology gets embedded in there and AI becomes part of the transaction process, we will see that. But it's not going to address the needs of, let's say, mobile applications or primarily customer engagement applications. These are mostly for what we call systems of record, where you have very high transaction volume happening in the backend. So that's what we see. We see that the backend continue to be, on these solid mainframe systems, wherever it makes sense, but then also a lot of distributed systems on the front end and alongside working with it.
And this ties well with what you said earlier, that this is a hybrid environment that we're going to live in, even in the digital versus quantum versus mainframe versus distributed. We're still going to have that quantum or hybrid world.
Yeah, indeed.
All right. So Amit, let's switch to the next segment. Let's talk about what we call as the lab for the nation. So talk to our viewers about some of the unconventional problems that you have uncovered while you're trying to build for India, and some of the problem statement that you guys have been able to solve or are solving.
Yeah. I don't know if it's unconventional or maybe people don't think about it so much, but it's very relevant to India. We in IBM think of generative AI beyond language, text, and videos and so on. One modality that we've been working on a lot is Earth observation data, weather and climate data. It's just like LLMs create this intelligence layer on all the text in the world, so that you don't have to go read the text. You just ask the LLM and sort of learned everything in there. And that unlocks the possibility of rapidly creating lots of new applications on top of that. Imagine we could do the same thing with satellite imagery. India and many countries have satellites across the world that are doing lots of Earth observation. In fact, India and ISRO and NASA recently together collaborated to launch the most advanced satellite called NISAR just last month. And these satellites collect huge amount of data about what's happening in the atmosphere, what's happening on the ground, and just slightly subsurface. And it's not just RGB, it's across multispectral or even hyperspectral, multiple bands. Now, imagine if we could create foundation models that can read all of that and understand all of those patterns across all of those spectra and locations of India. That's what we're doing. We've actually worked with NASA a couple of years ago to develop something called the Prithvi model, and it's in open for people to test it out. We also have a Prithvi version 2. Now we've been working with agencies in India, working with, exploring with ISRO's satellite division, exploring with the Ministry of Agriculture. And there's a very interesting and exciting problem that has come up, which is, in India, we have this Pradhan Mantri Kisan Bima Yojana. And many thousands of crores are allocated towards it in every budget. And it's extremely critical for the security and sustainability of our farmers in the country. But let's say you're the person who manages the claims for this, right? And now when a Kisan comes to you and says, my crop got destroyed, I need this much claim, I want to claim my insurance through that. You have a tremendous challenge because you're sitting in Delhi and maybe the farmer is somewhere in Andhra Pradesh. You have no clue what they grew, what was the damage, did the damage actually happen, not happen? And so that can lead to a significant challenge in efficient dispersal of these monies to the farmers who most need it, right? And effective use of our public coffers. Now imagine that if you could use this foundation model to scan across all the parts of India every week, every couple of weeks, and this foundation model could do crop classification and crop health detection, farm by farm. Now you actually have all of that insight on your fingertips. And so if someone comes with a claim, it's much easier for you to go back and see, is it a valid claim? How much was the damage? How much should they get? Right? And so you can optimize that. You don't have to underserve a very deserving farmer, and you don't have to overserve a less deserving farmer, right? And you can avoid all kinds of issues around leakage also, because there might be bad actors trying to game the system. So this is something we're trying to look at, and it's kind of unconventional, but it's extremely important for the country.
Yeah, that is truly unconventional, Amit. I couldn't imagine that all the weather information and location information, GPS information, and things of that nature, right? Or things like natural something happened or not happened. All of that could be converted into some form of a Wikipedia that somebody can just go and query.
Yeah.
That's a brilliant model.
Yeah. And also the satellite images, they take pictures. They have actual cameras that take pictures in many spectra, many frequencies. Terabytes and terabytes of pictures being taken of, every 10 meters of land across the country. And it has so much information, we haven't unlocked it. And if we could unlock it across agriculture, across disaster management, when we have floods right now, there have been, terrible floods in different parts of the country. If you can detect those immediately or very quickly and deploy resources to help, if states know, where am I, how much damage do I have, where do I have it, which district, so that they can quickly respond. If you can detect landslides, all kinds of disaster management or defense is another one. Urban planning, there's issues with encroachment on land. And if you can detect those as a district, you can do things. So there's so many things that happen on the surface of the earth in India that impact our lives, and it's a whole very exciting space.
Yeah, that's right. I hate to say this, but we are probably just scratching the surface here, given the amount of problems that it can solve, and in a lot of cases even proactive. So, for example, if as an insurance company, I see that a particular farmer in a particular part of the country has been impacted negatively, then the insurance company, the government agencies for that matter, can reach out proactively and help and offer support.
Yeah, you're right.
Yeah. Wow, beautiful. And those are cases that really, really, have a very positive impact on humanity, Amit, and they make me personally very excited.
Yep.
Amit, so there's a lot of collaboration in the work that you are doing, right? With government agencies, of course, with the larger IBM ecosystem for sure. But how do you guys work a lot with, let's say, startups, with academia, other research organizations? How does that collaboration work? Is it competition or do you work collaboratively?
We do a lot of collaboration at many levels. So we have peer-to-peer projects that between, let's say, a researcher in IBM and some faculty member in some institute like an IIT or a triple IT, who may have common interest, and they run project, do some collaborations together. We also have programs, funded programs or multi-year programs, like we have some with IIT Bombay, IIT Delhi, Indian Institute of Science, where multiple faculty members there would be running different projects with students and with IBM researchers as co-mentors. And a lot of that results in really strong scientific publications that come out of India in the top journals and conferences. It results in a strong talent pipeline because the PhD students get mentorship from our folks in IBM with a very industry-oriented practical lens to the research problems. It also gives, opens up avenues. For example, one really thing that I'm really proud of is we had this program with ISC for the last 4 years, which started off with hybrid cloud and AI. And then as quantum has been picking up, we said, hey, why don't we have a project that looks at how quantum plugs into the hybrid cloud concept? And some great papers have come out of that. And now, the faculty members there have a foundation and a confidence to actually develop bigger ideas of their own around quantum. And that has happened, to some extent because of our collaboration. The other way we do is, especially since last year, last couple of years, I would say, is through this AI Alliance. AI Alliance is an alliance of organizations across the world. These can be academic organizations, government labs, startups, big companies who say that, look, we want to build AI in the open and we want to do it transparently. So any organization can join the AI Alliance and become a member. IBM and Meta have sort of been championing this because we are both committed to an open source approach to AI. And last year, we saw a significant expansion of membership from India. We have startups, some of the hottest startups in the country. We have nonprofit entities who work in AI. We have academic institutions. We have big companies, all Indian, who joined last year. We came together, had technical meetups, and found common areas of interest. One very interesting project that we did was with IIT Bombay and Bharat Gen, where we said, look, if you take these big models that are being developed, they're great, but they don't really work as well for all kinds of Indian languages and use cases as they do for Western languages and use cases. Now, while India will develop our own sovereign model that can reach that scale, in the meantime, can we take some small, how do we make it easy for anybody in India to take a small model and tune it really quickly to make it very effective on a specific use case and on a few Indian languages? If we can create some open source technology like that, it can unlock faster value creation for India. So we partnered and we actually took an open source project that we had called Instruct Lab. And working with IIT Bombay and Bharatjan, we showed how that can be used with Indian languages on the Bharat Nyaya Sanhita, which is the whole legal document of the country, so that any citizen who may have some issue, like somebody damaged my car, somebody stole my thing, and they want to know what does the law say about it, you can ask in Hindi and it'll do a really good job. Which if you do without this tuning approach, it doesn't work that well because it's not so good in the domain. And so that whole pipeline, that approach is in the open, and we hope more people will pick it up, make it better. Right? So there's these different ways we engage with the ecosystem.
Yeah, no, the brilliant and some of the examples that you gave, they are very, very pertinent. Especially, we don't realize it. That's how you started this conversation. But there's a lot of impact that common people are able to take advantage of with these technologies, and it's really inspirational to see that you and IBM Research attacking those problems. Uh, not just one technology, but multiple technology, and truly take a problem-oriented approach rather than a technology-oriented approach.
You're totally right about that. A problem-oriented approach is so important. Yeah.
All right. So with that, we go towards the last segment of our show, which is the rapid fire round.
Okay.
All right. So here's my first question to you. What is one technology trend that you believe is currently overhyped?
I would say there's a lot of hype, but one that comes to mind is artificial general intelligence. I think we should right now focus on artificial useful intelligence before we worry too much about that.
I like the term that you said, artificial useful intelligence, and I'm going to borrow it without giving you credit. All right. Love that term. Okay. So the second one that I have, which book, technical or non-technical, has most profoundly shaped your professional thinking?
There's actually two books that come to mind, if that's okay, because I really like both of them.
Yeah.
One is Dare to Lead by Brené Brown. It talks about many things. The thing that I really took away is how to be vulnerable as a leader with your teams. And then the other book is called The Geek Way by Andrew McAfee, which talks about how companies today, need to adopt, how you can adopt a geek way to be a much more effective organization. So these are two that I really draw upon.
All right, that's great. So, viewers, if you're watching this, here are two books that one of the most inspirational leaders in India loves to read. So, make sure that you read those books. All right, the third one I have, that if you had to describe the relationship between humans and AI 15 years from now, in the year 2040, what do you think it would look like? And I know, things are changing every day, and which is why my question is too broad, just 15 years from now, not 5 months.
I don't know if the perfect word, but unassuming. I think it'll be so common. We won't be thinking about it that much. We'll be thinking about something else, but just using it in everything that we do, like a car or a phone. So unassuming.
Yeah, I think that's a brilliant way, Amit, because I had one of the viewers some time back, Jeetu Patel, who's the chief product officer at Cisco, and he also said something very similar, that when artificial superintelligence or general, whatever term you want to call it, right, when it comes in, it'll just be invisible, right, because it will be so much ingrained in everything that we do that we'll barely notice. We'll just grow with it.
We'll be used to it.
Yeah, exactly. You'll be used to it. So yeah, love the answer. All right. The fourth one, what is one fundamental skill that you would advise every young technologist in India and the world to cultivate today?
Yeah. I'd say applied curiosity with a growth mindset. So there's
Love
a
it.
lot in there.
Yeah,
Every technology will become old in a year. So
yeah. So if I were to unpack it, Amit, what you're essentially saying is be curious about solving problems, and have an open mind towards growth, right? Because if you have learned something today, like GPT, when GPT first came, ChatGPT first came, people became experts, but then something else happened. Gemini came, GPT-5 launched.
Yeah, and I think the curiosity means you no longer can say I've learned enough and I know how this works and I can keep things going in my career with that. You have to keep digging. So if you know how GPT works, you better understand, or you know how to use GPT, you better understand how it works also, as an example, and then apply it. So that's why I said applied curiosity with a growth.
All right. Okay. That's a great lesson for youngsters today. And then the fifth one, if you could use a quantum computer to solve one single mystery of the universe, what would it be?
Yeah, that's a tough one. Because there's so many mysteries. Maybe a practical one, how to do safe nuclear fusion be a good one. I think it'll help us achieve sustainability and will also probably help us understand some mysteries of physics mysteries of the universe.
Yeah, and that's a very good one. That ties back to the sustainability that you were talking about earlier. If you're able to solve the problem, then it leads to sustainability in the longer term. Yeah. Brilliant, Amit. So that was the end of the show. Thank you so much for taking the time to talk to our viewers.
Thank you, Arun. Really enjoyed the questions and the discussion. Thanks for your time.